So good afternoon, everyone. Welcome back to the day 4 session 2. Our morning speaker is not able to continue his lecture on the said topic because of his busy schedule. So today we have eminent speaker Dr. Nitin Dhote. He is the head of the Department of Electrical Engineering, St. Vincent Pallotti College of Engineering, Nagpur. Dr. Nitin Dhote sir has did his graduation in electrical engineering from VNIT Nagpur. He has done his post graduation in power system from Government College Amravati. He has done his diploma in business management and pursued his PhD degree from RTM Nagpur University. Presently, he is holding the charge of head of the Department of Electrical Engineering and professor in St. Vincent Pallotti College of Engineering and Technology, Nagpur. He is handling coordinator of internal quality assurance cell, that is IQAC, of the institute. He has almost 24 years of teaching experience to UG and PG level, published 34 research papers in different international conferences and the journals. Even he has visited Portugal, Germany, Thailand for the presentation of a research paper in international conferences. He is a recipient of a research grant of around 50 lakhs from different government funding agencies. He has published 3 patents in the National Journal of Patents and published 2 copyrights. He is the reviewer of many reputed international journals like IEEE, IET, Taylor and Francis, KIEE, etc. So I welcome you, sir, for the post-noon session in optimization tools and techniques for solving real-world problems in the field of electrical engineering. Sir is going to speak about the fuzzy logic application for detecting incipient faults in the transformer using DGA. So I request Dr. N.K. Dhote sir to continue with his talk. Sir.
Thank you. Thank you.
Thank you, sir.
I will share my presentation.
Yes, sir. Yes, sir, it is visible.
It is visible?
Yes.
So I would like to know whether prior to this any session on the fuzzy logic was conducted?
No, sir. On fuzzy logic, it is not conducted.
No. So today's topic, the presentation is fuzzy logic application for detecting incipient faults of transformer using DGA. DGA stands for dissolved gas analysis. So we'll come to that, the DGA and transformer faults later, and we'll know about what is fuzzy logic first. So fuzzy logic is already well-known word to all of you. Fuzzy logic is a Boolean logic which handles the concept of partial truth, which truth values between completely true and completely false, like the partially true, partially false, either completely true or completely false. Then it is a multi-valued logic that allows the intermediate values to be defined between conventional evaluations, okay, like linguistic variables like yes, no, true, false. Again, it is a Boolean logic. So again, we get the partially true, partially false, completely true, completely false, black, white, etc. So Lofty Jade, a computer scientist at the University of California, originated the fuzzy logic first. Now, what are the advantages of fuzzy system over the crisp system? The definite values. Okay. So first one, fuzzy logic has the fewer values. For example, we have the values between 0 to 10, varies from at the step of 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can have the range of these values, which will be the fuzzy. Like for example, low will lie from 0 to 3, then medium will lie from 4 to 6, high will lie from vary from 7 to 10. So if you take the Cripps value or definite values, the values are more, that is 10 values suppose. And if I take the ranges of it, it becomes the fewer. So advantage of fuzzy is that it has a fewer values as compared to the Cripps or definite values. Then it has a rules and decisions are required to describe the input-output relation. Then the fuzzy terms are linguistic. These terms are generally used by the normal people in his daily routine. So it has a well-known term to the normal public. So linguistic or non-numerical variables are used, so it is well known to the common people, and it is just similar to the way human thinks. Normal people will not think in terms of the value; it will think in terms of the range, whether it is low, medium, high, whether it is true or false. So it is more related to the human. Then values are more accurate because it doesn't give the exact value, it gives the range, so it's more accurate and stable than one with the conventional control system. Fuzzy logic is tolerant of imprecise data also. Then fuzzy logic can be built on the experience of the expert. So fuzzy logic uses some database as well as the rule. So it learns from the data and database. So more and more data is updated, fuzzy logic becomes more and more perfect. So it built on the experience of the expert system. So it is some sort of expert system, which you can say. Then complex information can be represented by simplified rules, and this system, as compared to controllers are concerned, the price is concerned, the fuzzy logic controller are cheaper than the conventional controllers. Now we'll see the components of the fuzzy logic based controllers. Now first one is the input. So generally in all our engineering system, the values are the Cripps, definite values are there, like just I told you 0 to 10, 1, 2, 3, 4, these values will be there. This value available as the input to the system will be always definite or Cripps. And if you want to use the fuzzy logic controller, very first thing that you need to do is that you have to convert this Cripps value into a fuzzy values. Like suppose we have some input varies between 0 to 10 with values 1, 2, 3, 4, 5 up to 10. So these values you have to first convert into fuzzy values. Like I can divide it in the range low, medium, high. Like from 0 to 3 I can say it is low, 4 to 6 it is a medium, and 7 to 10 it is high. So very first step is that whatever the input we have to first convert, which is Cripps and definite, we have to first convert it into fuzzy value. Then fuzzy logic has fuzzy logic base. It has a data which is saved in it out of the previous experiences. Whatever the data is given to the fuzzy logic controller, it will be saved in the system and it will use that data and rules and will build on the experience. So it has a database which has the data as well as the rules also. Then it has a fuzzy inference engine, okay, and then it has a fuzzy to Cripps defuzzification, because the output most of the time required a Cripps value. The fuzzy controller take the input as a fuzzy and gives the output as a fuzzy, but most of the time and the output we want the definite output or Cripps output. So we require the fuzzification at the initial stage as well as defuzzification at the output stage. So this will convert the fuzzy output, whatever we get, into a definite values, and then your output will be a real value or definite value. It will convert the linguistic variable to a real variable, the defuzzification. Now these are the steps. Fuzzification, it is the process of classifying a variable using membership function and a degree of membership. Okay. Different type of the membership function are used for the input generally, maybe the triangular, trapezoid, Gauss-Seidel, and different depending upon the input we have a different membership function for the fuzzy. Then the fuzzy knowledge base. Okay, it consists of the group of facts and fuzzy rules, which is extracted from the experts from the our over earlier experiences. We have seen that for the particular database, the particular thing has happened. We know the input as well as we know the output. So we relate the input with the output by certain rules. So some database we have out of our experience, out of the decisions from the expert. So it consists of the group of facts and fuzzy rules. Then in most engineering control system, the fuzzy rule are expressed as a if-then style. Then it has a fuzzy inference engine. It is an element which scans these facts and rules. What is the database it has? The fuzzy controller has a database. It will scan this database and it will provide the answer to the queries given to it by the user. So it will give the output. Fuzzy inference engine (FIS) will enable the fuzzy controller to give the output. It will scan the database. The rules are already stored. Database is already stored in the fuzzy controller. It will scan whatever the input it will get as the input get at the system. That input will be compared with the database and the rules. And FIS, the fuzzy inference engine, will scan it and will give the output. Now, there are two types of the fuzzy inference system. One is the Mamdani's FIS and Sugino's FIS. We'll see the comparison of Mamdani's FIS and Sugino's FIS later. And as the FIS fuzzy logic controller takes the fuzzy input and gives the fuzzy output, but in practical we need the real values or definite value or crisp values as the output, so that fuzzy output need to be converted into real values. Like suppose we get the output as low, medium and high, again we have to convert it back into a real values as output in numbers. So defuzzification is also required. So there are two FIs as I told, the Mamdani's and Sugino FIs. So this is a comparison. Mamdani's FIS has output membership function. Output membership, in case of both, whether it is Mamdani or Sugino, the input has a membership function. Like it may be a triangular, trapezoidal, or Gauss or parabolic, depending on the type of the input. But output, there is a choice. Output in one of the FIs, that is in Sugino FIs, is a crisp. So defuzzification is not required in the Sugino's FIs. Whereas in Mamdani's FIs, both input as well as output have the membership function. They are both graphical. Input is also graphical, output is also graphical. Whereas in Sugino FIs, output is either constant or linear and has no output membership function. So defuzzification is not required in Sugino. So most of the time, the Sugino FIS is used for the fuzzy logic, and it uses the weighted average system to get the crisp output. Suppose we have three range: low, medium, and high. So for low, what is the range? For medium, what is the range? And for high, what is the range? It will take the weighted average of all that, and it will give the final output as a crisp value. So we have the fuzzy logic toolbox in MATLAB. MATLAB is a tool which is normally used by the electrical engineers for all their research work. So here I will explain what are different tools that is used in the MATLAB fuzzy logic toolbox, and later I will take the one example of DGA, its application to the transformer fault protection, and I will elaborate that also. So now I will talk about the basic tools of MATLAB fuzzy logic toolbox. So it has the 4 components. First one is the fuzzy inference system FIS, as I told you that it is 2 types, Mamdani as well as Sugino, which scan the database and rules and gives the output, that is the FIS we need in fuzzy logic toolbox. Then membership function editor. So as I already told you, in both the Mamdani as well as Sugino's FIS, the input is always a graphical, so it requires a membership function. With membership function may be a triangular, trapezoidal, parabolic like this, depending on the type of the input we are using. And in Mamdani FIS, output function is also has a membership, whereas in Sugino, output is constant and linear. So memory function is required when the input or output is graphical. So it has a membership function editor. Then it has a rule editor. In database, it has a rule. So generally the rules are of the if then type, and we can use either and or type of the rules. Then it has a rule viewers. You can see the what are the rules you have applied, what is the input you have given, and what is your final output. So there is a rule viewer which will enable you to see graphically the input, output, the ranges of the input, and final value of the output graphically. So it has a 4-part fuzzy inference system editor. So we have to select the 2 out of 1, either Mamdani or Sugino. Sugino is only of if-then type, and it doesn't have the output membership function. Then membership function we have to use if either input or output is graphical. Input in both the cases is graphical, so it requires the membership function editor for input. And for Mamdani's case, if output is also graphical, we require the membership function editor. Then your rule editor to define the rules. Rules may be like for the particular values of the input, what is the output, if then type. If input is 1 is that, input 2 is that, then what is the output? It is that simple. So if then type of the rules are used here. So rule editor is used to define the rules, and rule viewers will enable you to see the input output graphically. So FIS editor, it is the main graphical user interface that is used to develop the FIS graphically. It is used to define the number of inputs and output of the fuzzy system. And how to get this FIS editor? In MATLAB command window, you have to just type the word fuzzy, FUZZY, at the command line. Automatically, this window will pop up. Okay, FIS editor untitled. This window will pop up, and it will show the 1 input, 1 output, and 1 FIS Mamdani. Mamdani is the default fuzzy inference system there, but we can change it and convert it to the Sugino FIS. Now it will show the 1 input. We can add the more number of inputs. If in the system you have the more number of input, it shows the 1 output, but we can double click the output variable icon to open the membership function editor. Then we can add the number of output. In the case of the Mamdani, the output is graphical, so we can have the membership function for the output, like the triangular, trapezoid. Same for the input one. Double click the input variable icon to open the membership function editor. We can give the membership function to the input, whether it is triangular input, whether it is trapezoidal input, okay, parabolic input. This we can give it, and we can add the number of input also as well as number of output also. Then membership function editor. So I already told you that for both the Mamdani or Sugino's FIS, input has a membership function because it is a graphical input. Okay, whereas output in a Mamdani is graphical. That's why it has a membership function. So membership function editor is used to display and edit the membership function of the input and output variables of fuzzy inference system. So you can check it here. This graph, when you enter on the input, suppose your service is one of the input. I have taken the one example that if depending upon the service and food provided by the hotel or provided by the waiter, we can say the tip will be given to the waiter. So my inputs are service from the hotel and food from the hotel, and output will be the tips. So this service and food are the input. I will click on this service. So automatically this rate mark is there. Membership function editor will pop up. And then this type of the sinusoidal membership function is default membership function. And if you want, we can change it to a triangular, trapezoidal, parabolic, cos. Different type of the membership function are there. To our requirement, we can have that type of the membership function for it. So here, sinusoidal, I have kept the sinusoidal as it is. Then both the service and food, I am using the same membership function. You can ask any doubt if you have. You can interrupt me in between and can ask. Then rule editor. So rules is a very simple and it is just like the if then type. So when you click on the FIS, the middle block of the membership middle block of the system, when you type the fuzzy, the middle FIS will be shown in the middle, left hand side input, right hand side displayed as output. When you click in the middle, the rule editor will open. So in rule editor, whatever the input we have selected will be there in the one of the block. Okay, what is another input? Second input we have given, that will be on another block, and output will be present in the one of the block. So this is the example of the hotel. Okay, and my inputs are service and food. So for the service, I can classify it as a poor, good, excellent, and no service will be by default there. Poor, good, and excellent. This I have classified the service into three parts. Then food also I can classify it as a rancid, then delicious, like that. The input range may change, and then depending on this input, that is service and food, I will be giving the tip to the waiter. That can be a tip I have classified as output, as I have classified as a cheap, average, generous, and then I can make a rule out of it like this. Suppose I have selected, now if it, then here it is or and is option is available here. If my rules require the or, I will use or. If my rule requires the and function, I will use the and. If your rule has either all options, you can use or. If your rule has depends upon the and option, this is also required. Service is also required. The food is also required for giving the tip. So I may use the and also. So depend. So here I have selected, suppose service I have selected poor and food I have selected rancid, then output is cheap. And then I will just click on the add rule here and my rule will be there. Then I can make another rule that if service is a good, okay, here I have used the or option. In or option I may or may not use. So second input is not used there. Tip is direct average. Whenever it is the and option, then it is mandatory for me to use the both the input. When it is the or, I can select the only one input also. So like this. The third rule you can say if service is excellent or food is delicious, then tip is generous. Depend on my previous experiences, okay, or experiences of the other people, we can collect it in database. That what is generally happen when service is excellent and food is delicious, we know that tip will be generous. So this type of rules we can get out of the experience or from the database, and we can store in the rule editor. And once it is stored in the rule editor, whatever the input we will be giving, it will be compared with those rules, and we will be getting the output accordingly. So it will scan our rule base. What fuzzy logic controller will be doing? It will scan the rule base. Okay, compare all the rules for the particular value of the input, and depending on the database we are having, it will give the output. So here we have to make the rules, our own rules, or rules out of the experiences of the experts. So this is a rule editor that we have to use. Then it has a rule viewer also. It is a facility. Here we can see the graphically what is the input given and what is the output graphically. So here we can see the service is something medium here, food is suppose poor, then what will be the output. So average tip is given. So the rule viewer is a graphical way of observing the input and output, rather than getting the crisp output. Crisp output is also saved in the MATLAB workspace, that you can also check the values of the fib, but graphical output for the fuzzy can be checked in the rule viewer. Okay, so this is about the all four important part of the MATLAB fuzzy logic toolbox. Okay, so that will be needed to make the any fuzzy system for any applications using MATLAB. So this fuzzy logic toolbox I will be using for the one of the applications of the electrical engineering, that is the dissolved gas analysis for transformer fault protection. Now dissolved gas analysis is generally the analysis done for the detection of the incipient fault. Incipient faults are different than your external faults. Incipient faults are the faults which are low at the initial stages. So in the general operation of the transformer, you cannot identify there is a fault in the transformer that will be at very low level. So it is a growing fault. If not identified, may be converted into a major fault. Okay, so it is used to detect the incipient fault. So in dissolved gas analysis, generally in whatever the fault conditions, whether it is at low level, maybe because of the overloading of the transformer, it's not necessary that every time there will be a short circuit fault or external fault, even at the overloading and minor fault, some gases, because your transformer oil is mineral oil, it is made up of the hydrocarbon gases, so some gases will be evolved, and depending upon the severity of the fault, the concentration of the gases will vary. It will be more, rate of the gases, evolution of the gases will be more. So whenever some fault, whether it is an incipient or major fault occurs, some gases from the oils evolves. Some portion of that oils gases are dissolved in the oil itself, and some gets evolved in the air. Okay, so dissolved gas analysis is a technique wherein generally a sample of 500 ml is taken from the bottom of the transformer tank, and there is a method of DGA gas chromatography. Okay, so that using that technique, the stirring of that oil, the heating of that oil is done, and magnetic effect is also used. And with that effect, we could know what is the concentration of the gases that is dissolved in the oil. And main gases which are available in the oil is the methane, ethane, then ethylene, acetylene, and hydrogen. These five gases are main gases which are available in the oil. Then later on, when the study goes in the dissolved gas analysis, it is seen that particular ratio of these dissolved gases, when these gases, the particular ratios of these gases are studied, it is of that for the particular combination of these ratios. Suppose here I am having the 5 gases, and I am taking the ratios, 3 ratios out of these 5 gases, like the C2H2 by C2H4, then C2H4 by C2H6, Okay, and then CH4 by H2. So three ratios, suppose I have calculating out of the gaseous concentration which I got from the transformer oil after doing the gas chromatography. Okay, and when I compare it with the physical experiences that for the particular type of the fault in the transformer, whatever these ratios, I could compare it, relate it with the type of the fault occur. So when these ratios are there, the fault was this. The fault may be not a major fault, it may be a arcing, partial discharge, okay, hot spot, some small spots will be there. So some this type of the fault occurrence can be compared, can be related with the ratios combination of these gases. And this is all about the dissolved gas analysis. So several studies goes on dissolved gas analysis, and then this ratio combination of these ratios are compared with the actual fault from where the oil sample was taken, and then they got rules out of that. That when these are the gases, because your fuzzy logic it uses the experience of the expert. So when you compare this gases ratio with the actual output, actual fault, we form the rule that when this is the particular combination of the ratios of the gases, this is the fault. So this database is then stored in your fuzzy logic database, and that is converted into rules. Okay, and then sorry, if the concentration of dissolved gases are measured for certain combination of the gases ratios, not only the type of the fault, we can also identify the severity of the fault. For example, we have the ratio C2H2 by H2 by C2H4. The C2H2 has C and H bonding as triple bonding, very high bonding between carbon and hydrogen when you have acetylene gas. Generally, the acetylene gas doesn't evolve in normal fault condition. Only there is a very severe fault, this gas will evolve. So suppose the acetylene value is more, C2H2 by C2H4 value will be more, value of the R1 is more. So we can not only get the type of the fault, we can talk about the severity of the fault. That severity of fault would be more. So it will give you the type as well as severity of the fault. All these gases has the bonding between carbon and hydrogen. This bonding in some cases is low, and in some cases it is high. So which type of the gases are evolved and in which concentration the gases are dissolved can give you to which type of fault occurred in the transformer. So ratios of these gases are divided. Okay, so we'll have different values, C2H2 by C2H4 or CH4 by CH2. These ratios are divided in the fuzzy range. So we may have the values varying between 1 to 10,000, but this value will require many rules. So it would not be possible for us to have so many rules. For example, if suppose I want to make a rule like when the C2H2 by C2H4 ratio is 1 and CH4 by H2 ratio is 5,000, then fault is this. So there can be such a 10,000 rules. So it's not possible to make rules on the basis of crisp value. That's why these ratio values are divided into ranges. I have defined myself that if value of the gas ratio varies between 1 to 10 out of the experience, I will call it as a low. If it is varying from 10 to 100, I will call it as a medium. And it is more than 100 to 10,000 also, I will call it as a high. So making the rules become difficult for the crisp values, so and it becomes easy for the ranges, that is for the fuzzy values. So that's why this gas ratio are converted into the ranges, and accordingly fuzzy rules are preferred. So any doubt till this part? Any student having the doubt? Now, what I will be doing, I will be showing it this application on the MATLAB Fuzzy Logic Toolbox. So that is not possible for me to open the MATLAB fuzzy logic toolbox directly here and execute. So that's why I have prepared a small video, okay, and that will show how it is executed. Any doubt in this part you can ask. Now I will be presenting a small video. Is it audible?
We'll select the concentration of gases. We are selecting the 4 gases.
Is it audible?
Sir, not clearly.
Okay, so what I will do, I will run and then I can elaborate also, or I can make it mute and run and we'll speak.
Fine, sir.
Okay.
Yes.
Okay, here I am taking A as a input, which will have the values of the 4 gases. For example, C2H2, C2H4, CH4 and H2. 4 gases I have selected. Their value I have selected as a 3141. C2H2 is 3, CH4 is 1. Okay, like this 4 gases are there, I have selected their values. Okay, now it is audible. Is it audible now?
Yes, sir.
So 4 gases I have selected, 3-1 and 4-1. And suppose these 4 gases, if I take the ratio of the gas, first gas, okay, 3, it will be 3/1, that is 3. Another 2 gases, ratio is 4/1, so that is 4. So gas 1 ratio, first ratio is 3 and second ratio is 4. Like this. Okay, and when you type the fuzzy in the command line, okay, this the FIS editor window will pop up, and then what you can do in new FIS, you can click on here in file, import, okay, use import. When you write the fuzzy here, this FIS editor will open. There will be one input, another output, one output, and one FIS. So I have to select out of Mamdani and Sujino. I have selected the Sujino using this file button. Then I have two ratios, so I will select the two inputs. So input 1 and input 2 I have selected. 4 gases, 2 ratios. So I have selected the 2 input here. Input 1 I will call as a ratio 1. And input 2 I will call as a ratio type. So I will click it here. After clicking the ratio 2 here, and I will change its name. So now 2 ratios, ratio 1 and ratio 2. In output, I have used Sujino FIS editor. In Sujino FIS editor, output has a crisp value. So it will not have membership function like the input here. I have single output, and output is a fault. Okay. Now, input is always graphical in a fuzzy system. So I have to define the membership function of it. So here, by default, for ratio 1, the triangular membership function is there. I want to change it to a trapezoidal. The reason is that this, suppose I take the range 0 to 3, low range of, suppose values of the gases, gas ratios varies from 0 to 10. And I want to classify it into 3 range, 0 to 3 as a low, 4 to 7 as a medium, and 7 to 10 as a high. So up to 0 to 2.9, I can say up to 10, 90% value, the value I can term as a low. And only the 10% part of it, I can say it is a between low and medium. 2.9, I can say 2.9 to 3, it is between low and medium. As it is not a fixed values. When I define the range, at the boundary condition, it may be defined as an intermediate value between low and medium. So here you can see when I define the low one, okay. So I have defined up to 1, it is low. And then from 1 to 3.6, I am saying it is between the low and medium. So that we have to define it on behalf of our, depending on our expertise. This low, medium ranges, we have to decide over. For example, here 1 to 3.6, I am saying it is between low and medium. 0 to 1 is purely low. Then 1 to 9, it is a medium. Okay, and 6 and then any higher value, it will be large. So likewise, you can choose your own function. This value is random. If you have to select your range depending on expertise. So these values, these 4 values are, I have selected trapezoidal function, so I have to give the 4 values. This lower foot values, then the upper 2 values, and then lower final values. So 4 values I have to define for trapezoid. Here, like lower value is 0, 1. Then this value I have defined 0.1. This value I have defined 2.9, and this value is 3. So up to 0 to 3, it is 0 to 2.9. The value is 6. Only for 2.9 to 3, it varies between low and medium. Like this. So I have again for the Every ratio 1 as well as ratio 2 will have three range: low, medium and high. These ranges I have to define based on our experience and database. So again here for medium, I am saying actually it is from 3 to 9. Okay. So I have converted it to trapezoidal. So 2.9 to 3, it will be between low and during the transition period, it may lie between low and medium. And in 3 to 6, it is medium. Again, we can say from 6 to 6.1, it may vary between medium and high. So if you get the values of the ratios in between that, that ratio may be considered as a medium and may be considered as a high, because these ranges are fuzzy ranges. It is not fixed ranges. So likewise, I have defined the low, medium and high ranges for the ratio 1. Okay. I can have, depending on the requirement, there can be several type of the membership function: triangular, trapezoidal, then Gauss, parabolic, sinusoidal. So depending on the type of the input, generally it will matter. So here I have the only ranges, okay, which are almost fixed for the 90% of values. So that's why I have selected the trapezoidal. The type of the input will decide the membership function of that particular input. And here you have to define the value. So same thing which I did for the ratio 1, same will be done for the ratio 2, because ratio 2 is also the gas ratio. So again it will have the low, medium and high range, and accordingly I will have the trapezoidal membership function for it, for all the three membership ranges of the ratio 2. Okay, got it? Okay, so thus I have defined the membership function for the both the ratios, ratio 1 and ratio 2, which are our input. Now what are the value we have given? 3 by 1 is our ratio 1 and 4 by 1, that is 4, is our ratio 2. Then we are using Sugeno FIS, so output is fixed, definite value. Now by default there will be only 3 definite values here, but suppose I want to classify my fault into 4. So I will add one more fault there. So when I click on the fault, this ratio 1, ratio 2 is the input, fault is the output. When click on the fault, I can have the membership function for the fault. So I will change the name. Add a membership function. First I will add one more membership function, because I want to have the 4 fault. So depend on me. Suppose I am having the 10 fault, I will add 10 functions there, like. Okay. So now there will be 4 membership function. That's 4 values of the fault. Now suppose MF1, I will change the name of that now. MF1, I am saying it is a no fault. Okay. MF2, I will edit this name and I will call it as a low fault. MF3, I will call it as a medium fault. And MF4, I will call it as a fault. Now here I have not given the actual name of the fault for understanding. Just I have given the severity of the fault. No fault, low severity fault, medium severity fault and high severity fault. Okay, like this. So like this I have no fault, low fault, medium fault and high fault. Okay. Then I will go to the, again I will click on the edit there and I will go for the rules. And when I go to the rules, these 3 blocks will appear here, because I have 2 ratios and their membership functions are low, medium, high for ratio 1, for ratio 2, low, medium, high, and for fault also no fault, additional one, no fault, low, medium, and high. And now I can make a rule out of this. Whatever the experience I have about the transformer and what are the gases evolved in the fault condition, with that experience I can prepare the rules depending on the survey. It requires a survey. So if ratio 1 is suppose low and I have clicked here, ratio 2 is medium, I will say fault is low. If ratio 1 is low, ratio 2 is low, there is no fault. And I have to click on the add rule. So I can have any n number of rules here. Okay, for this combination, I can have n number of rules. These rules will be based on the survey we did in the transformer industry, depending on the fault type. For the particular type of the fault, what where the gas concentration evolved, dissolved in the transformer oil, that we have identified, and accordingly we'll make a rule, and that will save in the database. Any doubt? Can ask. Am I audible?
Yes, sir, you are audible.
Like this rule you have to prepare yourself. You can have the load forecasting. If demand is this, supply is this, then how much should be what? So this application may also be applied in the load forecasting. So we have made n number of rules here. Then what we have to do? After the rules are done, we have to export it to the workspace. And here untitled will give the name, any name of your choice. Here I have given the name as a DGA new. So earlier I have exported the gas ratios 3 and 4 in the workspace. Now whatever the FIS I have prepared, that also I have exported to the workspace. So see, DGA new appear here, and A is the gas ratio, 3 and 4 is appeared already there. Now I will come back. Okay, now I will close it. Now I will make a small simulating model here. Which I already prepared earlier, that I will import. Open simulating model. This is already prepared by me. Making it very simple, we have to use the commonly available block in the Simulink to make this model. We don't require any difficult blocks for making the Simulink model here. See, what we have done here, we have the gas ratio stored in the workspace, MATLAB workspace. For example, ratio 1 is 3, ratio 2 is 4. So A was having the value 3, 1 and 4, 1. Then here I have used the input function, which will just divide 3 by 1 and 4 by 1. Where it is available, you can see sources, A, the matrix A is available in the workspace, seen in. So we have to use any matrix from the workspace here in the Simulink model. Okay, you have to use CMIN. Okay. CMIN. Yeah. So that is already available in the input. And I have it name. Then the input function. this is also available. User defined functions. Function. You have to use just function word there. And then you can have any mathematical expression there, division, multiplication. So here I have four gases, A1, A2, A3, A4, four values. So it will do the A1 by A2 and A3 by A4. Okay. Now, we have to give this 2 ratio as a input to the fuzzy logic controller. But fuzzy logic controller takes single input. So what I have done here, I have used the mux here. Okay. So commonly used block you can see, and they can have mux. In mux we can decide, double click it, and you can have any number of input. So you can have 3 number of input to it. The 2 ratios will be given as an input to the mux. Suppose you have 3 ratios, you will give 3 input as input to the mux. And then this gas ratios, both the gas ratios as together will be given as a single input to the fuzzy logic controller. This fuzzy logic controller with fuzzy viewer, this block is available in the library browser in fuzzy toolbox kit. So here a fuzzy logic toolbox kit is there. You have to go there. When you click it on, the fuzzy logic controller with reviewer is available. The input to this fuzzy logic controller is given as a ratios of the two gases. Okay. Then fuzzy logic controller, here you have to click, and here you have to insert the FIS we have made. We have made the FIS as a DGA new. That you have to include it here. DGA new I have included here. So that FIS, where I have had 2 ratios, they have the rules and the output, that will be stored in the fuzzy logic controller with rule viewer. Okay, and by clicking on this fuzzy logic controller with rule viewer, you will get a graphical input and output. But if you want the crisp output in values, okay, the crisp values can be saved into workspace also by using this output function, fuzz ans. Okay, output function. So that value will be stored in the workspace also. Okay, you can see the click on the sinks, seam out. When I use seam out, whatever the output value, crisp value, I will get it there. Like I was getting 0.25, 0.5, 0.75 as the output after the rules. That values will be stored in the workspace back. So you can get the output in the rule viewer also, as well as in a workspace also. So like this. So now, if you run it, okay, when you run option is there in a Simulink model. This run option is there. When you run it, you will get the rule viewer. This type of the rule viewer you will get. Your ratio 1 is almost medium. Then ratio 2 has this values. So you can see this is the final value. Your fault level is medium. For 1 it was high, and for 0.75 it is medium. So it shows somewhere in the middle, dark blue value. So graphically also you can check. This is a very simplest example. For more number of rules, you will get different diagram. So your fault is of the medium type, like this. So this is your output. This value 0.75 will also be saved in the workspace. So this is about the demonstration how you can use the fuzzy logic toolbox. So that is all over from my side. If you have any query, you can ask. I hope now you will be able to use the fuzzy logic toolbox for any other application that you want to use for the electrical engineering problem.
Thank you, sir,
Uh,
for your valuable guidance on fuzzy logic. That was really nice session, sir. And you have shown it with examples, so that was clearly appealing for everyone. Thank you, sir.
okay.
Yes, participants, do you have any queries related with today's topic?
I will share the PPT and video if you want to view.
Yes, sir.
Yes,
Sure,
sir.
sir.
Yeah.
Sir, yes, sir. Actually, recording we are doing, so
Yeah, that
recording.
is not needed as such.
Yeah, and fine. If you
Thank
share your PPT and video, it will be good. Fine. Okay, sir. Thank you so much, sir.
Thank you.
So, yes, sir. So, with the permission from the speaker, I just end today's uh, talk. We'll meet tomorrow again at 11:30. Tomorrow we do have only one session, and I just request all the participants to join 5 minutes before. It would be good so that the speaker, the expert, cannot get disturbed. So, thank you so much, sir. Thank you so much again.
Yes, 1 minute, sir. Before leaving this session, all are requested to fill feedback form and attendance sheet. Madam
Uh,
has already shared that link.
Yes. Sir, Shahakar sir, HOD sir from Pote Patil College Electrical Department is also there. Shahakar sir, do you want to speak something?
Good afternoon, sir.
Uh,
Hello.
Dote sir? Dote sir? Dote sir?
I guess he is not there.
I
Anyway,
think,
sir,
yeah, no issue.
it was
So,
nice session.
yes, sir.
It was really nice session. In fact, it add a lot of things to our knowledge also. I'm expecting the same as Madam said. We are expecting that all the participants they are going to join the session before 5 minutes. See, we really want to start the session on time. So it's a humble request to everyone, all the participants, please join on time.
Yeah, thank you, Shahakar sir. So, Telang ma'am, shall we close the session?
Yes, sir. Yes, sir. Hope every participant they have completed these two formalities related with attendance link